All right, we're gonna get started. We're gonna talk about bypassing EDR by DLL sideloading in C#. So a title filled with mystery. I'm sure we're all wondering what we're about to do today. I am Gary Lobermier. I work as a senior adversarial security engineer for Northwestern Mutual. What that means is I'm a red teamer, I'm a penetration tester, tech nerd, right? So what are we gonna talk about today? We're going to talk about a technique that we're using here, DLL sideloading. We're going to look at the DLL structure. We're going to look at EXEs that'll load a DLL for you. We're going to find out how to find exports or functionality inside of those DLLs. We're going to write that DLL in C#, and then we're going to nullify everything we just did by showing you a couple of tools that'll do that all for you. So I think we should get started. First off, what do I mean by bypassing EDR, right? The way I've looked at it is kind of like this. I've got this same source code that I've been using for who knows how long, right? And it's just standard shellcode runner. Like you might see like a virtual alloc, right? Mem, create thread. I'm using heap alloc, heap create, and then a function pointer. But same thing I've been using for a long time, right? It's been working for a long time. I've noticed lately if I compile it as an EXE, EDR kind of steps in and says, hey, listen, that's a globally unique EXE file. There's entropy if I'm keeping shellcode in there. You're doing some network calls. I'm sorry, pal, that's just not flying, right? And so that EXE is kind of burned to me. But what I did notice is if I just take the same source code and compile it as a DLL, perfect, send it, it's fine with it, right? It loves it. So what I need now is, because I'm lazy, I'm not gonna rewrite my shellcode runner, right? I just need a way to execute that DLL. So that's what we're going to do today. We're going to find a way to execute those DLLs. The technique we're going to use, DLL sideloading. Bet you would have guessed that. So what is DLL sideloading? I kind of feel like that depends on who you ask. If you would have asked me this like 3, 4, 5 years ago, everyone kind of defined DLL sideloading as like, hey, weird side-by-side manifest file explicitly defines where the DLL gets loaded from. And I think now if you ask people what DLL sideloading is, they kind of just conflate it all together like, it might be a manifest file, it might be like a load library call that just whatever, it's a search order hijack, right? And the DLL lives in the same directory. So for the most part, what it means now, if you read articles about DLL sideloading now, it just means an EXE that's going to load the DLL kind of adjacent to it, right? So that's kind of what we're going to do. We're going to find a Microsoft signed binary that loads, or rather side loads, our DLL. We're going to place our DLL in the same directory of that, and we'll get execution through that signed binary. Like I said, it's kind of conflated with DLL search order hijacking. I think at the end of the day, nobody cares anymore. Like the DLL loads, whatever, right? There are some good articles. I'm going to find a place for these slides so you guys can get to the references, but Mandiant has a really good blog post that's basically a step-by-step for what we're going to do today. I promise I submitted this talk before they released that blog post. Hijacklibs.net is kind of the project that inspired this. So if you're looking for more DLL sideload options, great place to start. They basically have several hundred of them and different utilities that will load those DLLs. So we are going to start by finding a vulnerable EXE. So there's a couple of ways to do this. What I like to do is start with some signed binaries. So Microsoft's SDK can be downloaded from MSDN, whatever it is. I like that one because it's a boatload of Microsoft signed binaries that aren't on disk already. That's kind of important sometimes. Some of your security solutions will look at DLL sideloading of binaries that already live on disk and kind of just kill it. So for example, if I take something that normally lives in System32 and I just copy it out somewhere else, it might sideload DLLs. But when would I ever do that, right? Every single user on the machine has a path entry that points them over to System32, so I can type ipconfig and it just resolves, right? It finds it in System32. Well, a lot of your security solutions look at that and say, okay, why would ipconfig ever exist anywhere else but System32, especially if there's a DLL next to it that is, who knows what it is, right? So I prefer to bring my own Microsoft signed binaries, partially because like if you look at what we're going to look at today is OLE view. The only way that ends up on disk is if you download it to some random directory, right? So the perfectly normal use case is that it lands in a random directory and needs the supporting DLLs in that same directory, or it's not going to work. So what we're looking at is, like in this example, you see this is the SDK, and the SDK, like that dxcaps viewer.exe. I don't know this, I didn't look at it, but right next to it, there's a couple of DLLs like dxcompiler and dxil.dll. Probably sideloads those, right? Like I don't even have to look to kind of make that guess, but we are going to do more than just guesswork. The way I typically go about this, I run the exe I want to use, and then watch it with the sysinternals tool procmon, process monitor, right? So check for DLLs, check for result not found, right? Or I kind of like to just monitor a specific directory and copy the exes into that directory to see everything that it's about to do, right? So we are going to do that, and we're going to test it with the Microsoft signed binary OLE view. There's a couple of reasons for this. It's a really good like example case because it does a few things for us that make it clearer, I think, but still kind of teach us the process. So we are going to copy OLE view to ctemp exes. We're going to monitor that directory for not found, and we're going to get a bunch of stuff back here. We'll go through this live, so don't worry if you can't see it on the slide. It's going to do a couple things for us, so let's just do it. Love the not responding, that's fun. So this directory is the SDK. There's a bunch of different versions of a bunch of different files in here, including OLE view. What? Did it freeze? Okay, hold on. Is it, how about duplicate? Better? Right on. And Explorer just crashed. I might have. This thing's riddled with pop calc disease. All right, so this time this is the SDK. So OLE view here. Gonna right click it real quick and just show you guys properties, digital signatures, right? So we've got a Microsoft signed certificate. We like that. There's a couple of reasons we like that. We'll get into them a little bit. And all that was for nothing because it was already in here. So, all right. Procmon. Of course, I have other projects. Right. All right. Clear it. Oh my God. Should have brought a faster machine. Thanks, NM. So OLE views and ctemp exes, there's no DLLs in there right now. So basically what's going to happen is it's going to search for those DLLs in that directory, and not find them. So when I run this, one of the reasons we're using OLE view is because of this pop-up box. Makes it a little bit easier to see exactly what's going on here, even though not everything will work this way. First thing it calls out is could not find iviewers.dll in this directory, right? Probably start there, right? If you don't, most things won't give you that like verbose of an error message, right? But we're gonna go verify that. If I pop over to OLE view here, look at it in procmon, we see a lot of things. Any of these name not found, pretty good thing we wanna look for. We see a lot of DLLs here, right? One of them is iviewers.dll. So in theory, almost any of these can be used. That's not necessarily always true, but most of the time you can find something that works. So we know iviewers.dll is not found in ctemp exes. It's looking there for it. We also know that it barked at us that, hey, I didn't find it there. So we're gonna use that as our starting point. What we want to do now is we want to inspect that original DLL. We want to say what's going on in that DLL that we might need to replicate. So first thing to know is that DLLs export functionality to a program. So when I have OLE view launching, it's looking for iviewers.dll because it says, hey, I don't have this code natively, but I can work with it through this DLL, which does give me that functionality. So load the DLL, call the function, and we'll get that functionality, right? That's the idea. And our exe expects that functionality, which means if it looks at a DLL and it doesn't find that functionality, it's not going to work. So we can explore the DLL, a thing called the export address table, to see what functions are going on inside of that DLL. There's a couple of tools to do this. CFF Explorer is a really popular one. If you're like me, the first time you go to that website, you're like, sorry, pal, I don't know if I trust this, right? Like, it looks like it's been running since 1998. There are some other tools out there, like PEBear is a GitHub project that basically does the same thing. It's a little bit newer interface, same thing though. And then if you're more of a CLI junkie, object dump, CLI version to get the exact same information. So if we look at our iviewers.dll, we can open it with CFF Explorer. It's gonna show us this information. So it's basically just showing us the structure of that DLL, right? One of the things we really care about is the export directory. That's where it's going to list out all of the functions that are inside of that DLL that an application can call. So we care about those because we need to recreate those functions so that when application A calls that DLL, it can go call that exact function that it's looking for. So if we go back to the original DLL inside of the SDK, look for iviewers.dll, here it is. Open it with CFF Explorer. There's this export directory. This is another reason we're using OLE view as an example. There's only 4 functions in here, right? Some DLLs can export hundreds of functions. Makes for a harder time to manually write a POC if you have to manually write several hundred functions. 4 of them we can handle, right? So these 4 functions are what we care about. DLL can unload now, DLL get class object, register server, and unregister. That's what we want to rebuild and recreate. So writing that DLL, you're going to see a lot of examples for POCs that are written in C or C++. I like C#. That's all this comes down to. I just like C#. So that produces a little bit of a problem. When you compile C or C++, you're taking the language that you write is getting compiled all the way down to the CPU level, right? It's getting compiled down to managed code, machine code, unmanaged code, or like native code. These are all kind of synonymous terms. And all it means is that we're taking our language and bringing it all the way down to the CPU level, so it's running it through the CPU's instruction set, right? It knows what to process. That's not how C# works. There's other languages, C#, Java. They don't compile all the way down to native code. They compile like halfway down, right? They compile down to what's called bytecode, managed code, intermediate language. So those are all synonymous terms to say, I'm gonna take your code, compile it down halfway, and then underneath that is gonna be a runtime. And that runtime is what handles the rest of the compilation down to the machine code layer. So that's kind of an issue for us because the way those two things load and their structures is essentially different, right? So the result is that methods or functions that we create in C# aren't going to exist in an export address table. They don't need to. That's not how it works. I can still call those C# DLLs from other assemblies and call those functions. They don't need to be advertised, right? So applications like OLEview, they won't see anything. They'll look for the export address table. They're not going to see an entry there, and they're going to say, sorry, pal, I was expecting this function. You don't have it, so I can't run. And actually, we're going to keep going into this one and just build it out right away. So we're going to write it in C#. We're going to write those same functions, and we're not going to export anything, because that's just how it works, right? The source code is going to look a little bit like this. There's going to be the standard shellcode runner I was talking about before inside of a method called conference. And then all of those other functions, I'm just going to create them as methods that, if they get called, will in turn call conference. And that'll bump up our shellcode runner. Then we're going to go look at it. We'll compile it, look at it, see that there's no exports in there. I don't suppose any of that is like even remotely visible from out there, but it's what it looks like. Embedded shellcode, base64 encoded. There's a multi-byte XOR in here that's encrypting it. So kind of standard obfuscation techniques, right? And then at the end of the day, heap create, heap alloc, and a delegate function pointer to actually point the CPU to that memory address and start executing your shellcode. So if we take this, no exports, build it. Here's our DLL, no exports. We'll take a look at that, right click, open CFF Explorer. And we see .NET directory, right? It identifies that this DLL is .NET instead of just an unmanaged code binary, but what we don't see is an export directory. So there's nothing there for OLEview to reference, right? So if I bring it over there anyway and I run OLEview, we do get a different error message. Another great reason to use this as an example, right? Basically, it's not the error message that says iViewers isn't there, right? It found it. But what it didn't find, could not find DLL register server function, right? It looked, it can't find it, it's not going to do it. So we did load our DLL. We're just not getting any shellcode execution at this point. All right, so let's manually export those methods. There's a really cool thing we can do with intermediate language. When we compile our C# down to the IL, we can disassemble that IL, which means we're going to kind of see what the runtime would see and how it would execute that IL. So what we're going to see is that the methods that we define are kind of right in that IL. And then the next thing you see is the call stack to that conference method, right? So in theory, you call this method, it calls the other method. So since we can see those methods inside, we can add our own export descriptor. And what that means is inside of the method, when we add that export descriptor and then reassemble it, copy it over as a DLL, it adds it to an export address table, right? So now we have this function being advertised in the way a traditional like unmanaged C or C++ DLL would export it. So you'll see something like this, right? The exact same thing we saw, manually exported. It will now have the export directory and then the DLL register server function. But we're going to do it. So we have our DLL here, no exports. We're going to copy that over, drop it into a different directory that has my disassembler. paste it into here. Copy and paste the commands because otherwise I will screw it up. So IL disassembler, put it out to a manual exports.il file and go point it to the DLL we just compiled. Notepad, that manual no exports. And we can see this is the IL, right? This is what the runtime is going to be processing. So if we just scroll through this, some of it is maybe over our heads. We don't really care. Some of it's pretty readable. It's pretty reversible from the IL standpoint, and we can actually see, this is a method. I defined this method can unload now. It has a call stack. Call stack calls the conference method, right? So this is familiar enough, we know what we're looking at. If I go down to, let's say, DLL register server, and I come inside of this method, .export, and save this, that's all I have to do. And now I can recompile it, or rather reassemble it. So IL assembler, point it to that IL file we just modified, say we want a DLL out, and then manual exports.dll will be the name. Now we've got manual exports.dll. Look at that at CFF Explorer. Now we have an export directory. And we have a DLL register server. So in theory, if we did this on all of the methods, cool. We have all of them exported. We should be good to go. Yes, but no. I'm lazier than that. What you need to do is get the DLL export NuGet package. That's how we do it under the hood. Get the NuGet package, and when you run this, it goes and does all that hard work for you. So what that means is now in your source code, all you have to do in C# is type DLL export, and it knows that it should take that function and export it to the address table. So you don't have to do any of that work. That's just how it works under the hood, right? So if we look at that, I have this prepped and ready to go already. It looks like this. It's the exact same code, but now every one of these methods has the DLL export decorator at the top of the method, right? So when I compile this, all of those functions will be exported for me. Exports.dll, check that out in CFF Explorer. We've got our export directory, and we've got 4 different exports in it. So C# now has the exports that we need. In theory, if we copy this over, we should have everything we need for a DLL that does what we want it to do. Exports.dll, copy that. iViewers.dll, that's the one that we know sideloads. Double-click OLE view, and there's our MSF Venom message box. Wish it was cooler than that. Message box doesn't feel cool enough, but it is what it is. So POC, just double-click OLE view. There's our message box. There's a question you should be asking at this point is why is this even working? Because at the end of the day, we just created an export and that's it, right? Why would the unmanaged code, OLE view, have any knowledge of what's going on inside of bytecode? And to be more explicit, that's machine code, right? It's compiled all the way down, and we just handed it something that's compiled halfway down and needs a runtime, right? So in my head, I'm like, well, this shouldn't work. It shouldn't know what to do with that. And if we look at OLE view in sysinternal's Process Explorer, what you're going to notice is that the DLLs that are loaded in OLE view do not include CLR.dll. There is no common language runtime by default inside of OLE view. So does anybody here speak fluent Spanish? Okay, so small number of people, right? Willing to bet everybody knows what that says, right? Kind of magic behind the scenes, but that's what's happening. The OS recognizes bytecode, and it kind of says, hold on, I know how to process that. So I'm just going to load the CLR for you. I'm going to plug it in to this process, and now I can run the rest of that for you. This is kind of a good tip-off from the C# tradecraft perspective. If you can get the insight into like where your normal CLR loads are, and you can kind of baseline what's not normal, it might be something to look at, right? It's basically indicative of C# where it shouldn't be. You might be saying, cool, I don't write code, right? Like, that's fine. You don't really have to. Under the hood, this is how it works, but there's a lot of toolkits that do this for you. I like the one by Optiv. It's a project called Freeze. General premise is you're going to give it the name of a DLL that you care about, like iviewers.dll. You're going to tell it what export to use, like whatever, and you can feed it shellcode. And what it's going to do is AES encrypt that shellcode, compile a DLL for you, and it'll have exports out there. There's also a current pull request that allows you to feed it multiple exports, and I've used that before and it works great. So you can feed it a DLL directly. So if you have the original iviewers.dll or whatever DLL you're sideloading, point it to that. It'll strip out all the exports, add them to the new one with the shellcode inside of it, and produce a DLL that surprisingly effective, to be honest. Something didn't work on one of my last engagements, and I went and quickly crafted up one with Freeze, and it worked great against unnamed EDRs. So this just broke OLE view, right? When I double-clicked it, it didn't launch anymore. It gave us our message box. To be honest, that's all I really care about, right? I just want the beacon, and I don't want anything else to be on the screen. So it worked like I wanted it to, but there are also ways to maintain application functionality. And what you're thinking of there is a DLL proxy. The reason I bring it up is because 100% what we just went through still perfectly adapts to that. The concept being we create a DLL that exports all of those functions, and now when the application calls our DLL with all those functions, our DLL can DLL proxy it to the original DLL. Because it's a proxy, that middle process will execute our shellcode, give us a beacon, and then hand it off to the original so that the application is none the wiser. It gets all the functionality that it's expecting. I use a project called Sharp DLL Proxy for this. What I like about this is it doesn't give you a DLL. It gives you source code for a DLL, which I think too many tools just directly give you a DLL, and that's cool for the like 3 or 4 months that it works. And then after that, the tool is kind of burned and you have to customize it anyway. Just give me the source code and I will get the skeleton that I need, and then I can modify that as needed. And for that reason, I've been using this tool for years because I can just go in there and say like, yeah, tweak this, and then it'll continue to work. But I get the structure of the DLL efficiently, right? Blue team. I'm not going to pretend to know what I'm talking about here, but I can at least give you a little bit of insight into what I think are opportunities. First off, like I said, there's a lot of security projects that, security tools that if they identify that tool already exists in System 32, there's no reason that it should be sideloading something outside of that directory, especially if there's that adjacent DLL. So that's something to look into if your security tool doesn't do that. I think like check out hijacklibs.net, grab one of those that normally lives in System 32 and just pop it out there and see if you get blocked or not. So that's why I don't use anything from in there. I can just bring my own, right? Grab the SDK and bring my own. Microsoft signed EXEs, really good chance that the DLLs are also signed. So if you're getting a DLL that's unsigned through, this bring your own DLL EXE that is signed, maybe an indicator, maybe something to pull on. C# specifically, right? We talked about those CLR loads. If you can identify what's normal there, that's kind of important. It's a good indicator that C# is running maybe where it shouldn't be. I asked my blue teamers for this information, so I'm going to tell you it and then have like deer in headlights looks. If you can baseline where your executables are running from, their exe and their original file name, and then identify non-standard directories where you see those running from in your environment, that might be a good way for you to kind of grasp like, hey, this is where it would normally run from, even if it's non-standard. So when we see it somewhere else, yeah, okay, maybe we should pay more attention to it. In theory, you can do the same thing with DLLs, right, based on your image load events. Sounds like it's harder. I did kind of fly through that. I think that's okay because we all want to get to the keynote anyway. There's a couple of things I'm going to plug real quick. One, there's Adversary Emulation Village downstairs. Does anybody check that out? I don't blame you. The sign is mislabeled. It says Advisory Village, so nobody's interested in that. The whole premise of that village is they give you like 3 different EDRs that you can test against, and they give you a dev box. And so the concept is like, go write your own malware, and if you can get past these 3 EDRs, we'll give you a prize. Immediately after this talk, I'm going down there. I'm going to run OLE view with iViewers against it and get a beacon out of it, and I already know it'll work against all 3 EDRs, so I'm gonna walk away with the cash. Second thing I want to plug, I am also doing a talk later today with my boss, Matt. It's called Attacking Unicorns. We are basically taking mini malware samples that we write, and we coined a term called threat injections. What we do is if you're familiar with like Atomic Red Team or MITRE's Caldera project, we do that. We built our own custom system. We execute all these attacks on our systems, hundreds of them per day, in the effort of automatically checking that our detections are working like they're supposed to. So routine controls validation, fully automated, pretty fun stuff. Other than that, that's what I got. Questions? Yeah. No, I haven't, but that's a good idea. So the question is if I've thought about contributing the DLL export NuGet package into Roslyn and make it part of the whole thing. So no, that's a fun project. I think the other maybe mic drop moment we could do here is, for what it's worth, I didn't prep this on the right machine. So this is a production machine with CrowdStrike actively running on it. So we did just load against CrowdStrike. I'm going to go do it against Sophos, Microsoft ATP. I use it against SentinelOne. I mean, if you get it across one of them, you're going to get it across all of them, right? So.
Would you be willing to share what the protection settings are on that CrowdStrike machine?
My blue team is probably already going to kill me for doing this on my production machine. They're back there like, yeah, I don't know. Not good enough? Yeah. Yeah, I'll get the slides up on my LinkedIn, my Twitter, and all that. Yeah. I don't know. As far as I know, it compiles down to what needs the CLR. But I think there's options in C or C++. I'm not a C guy, so I just know that one slide. We'll go all the way back to it if I can. All the way back. Yeah, so this slide almost indicates that C++ could be compiled down to CLR. I don't know. That maybe somebody knows more about that, and that might be maybe what you're thinking of too, because I was unaware that maybe it could be compiled to a CLR or all the way down to native code. Or it could just be, a crappy screenshot. Awesome. No other questions. Let's get out to that keynote. Thanks.